guys. So today I'm here to talk to you about primary productivity in temperate zones. My name is Ashley Rodriguez and I am here with the OOA, and I'm going to be talking to you about the importance of placing an array in your local coastal waters so that we can get more of a benefit and monitor the primary productivity that takes place within the local area. So basically, primary productivity is one of the single most important processes that takes place in our oceans. It takes inorganic molecules or substances and turns them into organic substances, which we as humans can use, as well as anything else that is living, and our environment benefits from it as well. So this is typically done using photosynthetic organisms in the ocean. That's going to be plants, algae, phytoplankton, but a majority of it comes from plankton, phytoplankton, stuff like that. So basically what these little organisms do is they take the sunlight and they take carbon dioxide that's already in the atmosphere, and they process it and turn it into organic molecules, including energy and oxygen, and we're able to then use that and breathe and live and all the above. So you guys can see how this is actually really important. That being said, did you know that 50 to 80% of our oxygen comes from the ocean, from photosynthetic processes? So that right there, primary productivity right there in the making, right? So how are we going to actually monitor photosynthetic processes? Because, that's a little impossible whenever plankton and phytoplankton are so itty bitty teeny tiny, we can barely even see them with the naked eye, right? So the OOA has actually come up with a device called an array, which monitors different levels of chemical, it does physical conditions, all kinds of different things, right? And so far we actually have 3 placed in the temperate zones, which is the North Pacific, which is the Endurance Array. We have the North Atlantic, which is the Pioneer Array, and the South Atlantic, which is the Argentine Basin Array. You can kind of see them over here on the map right here. I know I'm covering the bottom part, but the 3 that we're actually talking about in the temperate zone are going to be right about there. And the reason it's called the temperate zone is because it goes right along the equator, and the waters are going to be more temperate or warmer as opposed to the more polar regions, right? So over here, I actually included one of the graphs that was taken from one of the arrays, and we're going to be talking about the chlorophyll A levels that are in the 3 different temperate monitoring areas, right? So you can kind of see from the map, for the most part, the green and the yellow kind of stay pretty low, but over here we have some variation in the levels of chlorophyll A, right? And that's going to be, if you look really, really closely at the small writing, it is in the North Pacific. There you go. So that one is actually going to be the the Endurance Array. So that's going to be this one right here. You can kind of see there's California coast, and then there's up a little bit further, kind of Washington-ish area, I believe, maybe close to Canada. I don't know. Anyway, it's hard to tell from the map, okay? But you kind of get an idea of where it's at, and you can kind of see how close to shore it is, right? Even the one over here is pretty close to shore. The reason that this is done is because there's actually going to be more life closer to shore, which is going to be a more adequate description of the area, I guess, of just the ocean as a whole, because if you think about it, a lot of the life that happens is going to be in the more shallow areas that are going to be closer to shore, and that's where there's going to be more traffic, there's going to be more things that are going to be stirring up the tides, and there's going to be more mix and blend of the ocean, right? So basically, if you kind of see how it staggers over here, chances are that this has something to do with the season, because if you notice, it goes from about May to about August, which is going to be our warmer months, right? So that would make productivity higher. And it's also springtime, so there's going to be like algae blooms and stuff like that. So there's going to be more more creatures coming out and trying to enjoy the sunlight while it's around. So as a result, you can kind of see that depending upon the location, that chlorophyll A actually varies over time and the different locations, and it's usually higher in the spring and summer months. It's most likely due to the warmer temperatures, which we kind of just went over. But there's other oceanographic processes that could actually be attributing to that, those spikes in the chlorophyll A levels. Yeah, but if you kind of further look along at the Pioneer array, you can also see how close to shore that it appears, and that could also have something to do with it as well. But overall, what we want you to see is that we are actually able to measure primary productivity in a way. It is using different, looking at different levels of different chemical and stuff like that. But for the most part, anytime that there's chlorophyll, that's going to indicate that there is primary productivity going on. And the more primary productivity we have going on is going to be better for us in general, because it's obviously creating a lot of oxygen, and that's always a plus whenever we need that to breathe. So there you go. And I am out of here, but I will let you guys enjoy reading the poster, and hopefully you will consider the importance of primary productivity in temperate zones. Bye.